down here. I'm going to do everything I can to influence you to support Ukraine. Just so you know, you can check out anytime you want if you don't like my political agenda in this also. Okay, the agenda for
Uh-oh. I think we lost him. Kim, if you can hear me, we've lost your connection. Okay, it happens every now and then. So as soon as Kim's back on here. I want to thank everybody for attending too. Oh, from Brazil. Great. Australia. We've got 4 countries represented right now that I know of. It looks like Kim's logging back in. So we have Denmark, Australia, Brazil, and USA. And I think someone was going to come in from Mexico. Did you get logged in? And just so everybody knows, the session is being recorded. Okay, Kim, just go ahead and share your screen again.
So can you hear me?
Yeah, there you go.
I don't know what happened. I didn't do anything. I was talking like crazy, so I don't know, something happened. Well, I don't know how much of it all you got.
You had your agenda up, and that was about as far as it went.
So you didn't hear any of my nice voice from that point off.
No, I was trying to let you know that we couldn't hear you, but apparently you couldn't hear us because you were disconnected. So
that's weird. Okay, I don't know. I was pressing the small hide button down here, but I probably shouldn't do that then. Anyway, I'll try again. The agenda. We talked about I was almost getting through it, but we're going to talk about what NTIA is, and we're going to talk about how kbmW built inside. We're going to talk about the transport layers, or at least some of them available for kbmW. We're going to talk about the messaging framework, the WIB, it's called the Wide Information Bus Messaging Framework. And somebody might actually have heard about something called TIB, which is a messaging framework from Switzerland that is well known in banks and other places, costing a small fortune to use. And I got some inspiration from that many years back when I built the WIB. Then we're going to talk about the object notation systems like JSON, XML, and YAML, and CSV, and text, and other types of object notation systems supported by kbmW. We're going to talk about how it's doing logging. We're going to talk about the object relational management of data, and also about the data persistency framework that is built into it. And it's actually quite cool. Then we're going to talk about Link. It's not like .NET Link, but it's getting close, I would say. It's a very smart little thing to do complex things in a fast way. We're going to talk about a scheduler, which is similar to a T-timer, except that it's not a T-timer, it's a T-timer on steroids. So you can schedule everything for the ways you want to have scheduled things to happen. We're going to talk about SmartServices, and part of the SmartService is also talking about REST, how we are doing REST in kbmW. And then we're going to talk about SmartEvents, which are kind of Delphi events, but in a way that is making sure that we're not hard coding or hard binding events to code. So it's a publish subscribe based event handling system. And finally, we're going to talk about SmartBind, which is kind of a different way to do live binding. Basically, I've replaced live binding using SmartBinding instead, using a different methodology of doing things. So it's quite a long list, and we'll see how far we get with it. But let's start on with it. And I've just for the information, I have some reference materials you can go and look at if you want to know more about the details of things I'm talking about. It's our blog, and there's our homepage, componentsfordevelopers.com. And then there are some direct access to documentation, which contains something like 600-700 pages of white paper documentation. I don't know, I think I was pushed off again.
No, you're on.
Okay.
I turned me off so that it less bandwidth.
Okay, cool. Because last time it was happening like that, I couldn't hear anything either, but I was assuming I was still on. Anyway, we have 3 different types of tiers of kbmW: the Community Edition, the Professional Edition, and the Enterprise Edition. The Community Edition is a free edition, which do not contain any source. It's only supporting whatever Delphi version has been compiled for. So that means that for an older Delphi version, you will only be able to access an older version of kbmW. And for a newer Delphi version, you will be able to access a newer version of kbmW, whatever version of kbmW was available at the time that I was making a community edition. There's currently no community edition for Delphi 11. It's not because there's not going to be one, but it's just because I haven't been pulling myself together to do one at the moment. I've been busy with a lot of other things. The Community Edition is, as I said, free, and it contains actually quite a lot of the functionality that you'll find in Enterprise Edition. At least all those features that do not require recompilation of the framework to make it operate. And things that require recompilation is, for example, if you want to support a different database layer that is not part of the standard Delphi installation. Then we have the Professional Edition, and the Professional Edition contains full source for whatever is included there. It contains quite a lot of functionality. And then we have the Enterprise Editions, which contains the full multi. And basically, I will always recommend people to go for the Enterprise Edition, because if you're choosing the Professional Edition, you're going to miss out on something at some point in time. But, well, the few $100 extra for the Enterprise Edition is, in my opinion, absolutely worth spending on it. And right now, you are actually able to donate some money to Ukraine and get a free Enterprise Edition. And that means you're getting support for the Enterprise Edition also for 6 months after purchasing update support. So you can get all the updates for 6 months after. So that's a very
nice.
easy, very cheap way to get onto the Enterprise Edition. Okay, N-tier. Well, there are probably all of you know something about N-tier, heard about N-tier, because it's been something that's been going on for many years now. Back in time, we usually talked about client-server setup, and that was pretty advanced at the point in time. And a client-server setup is a 2-tier setup where you have 2 things that need to talk with each other to actually do the things that you wanted to do. And typically, the one tier is the client, and the other tier is the database. That's usually how it is. The one tier, well, then you only have one application that's not talking to anybody else, and that one application does everything that it needs to do. And then you have a 3-tier setup where you have 3 entities running it for doing your stuff, and it's typically a client of some kind, and it's a database on the other end, and then in between you put an application server that is making sure that the client is able to talk with the database in a secure and fast way. And the good thing about that is that now you can actually remove the stuff from the client that needs to know about what type of database it's talking with. In a typical client-server setup where you have a database and a client, if you want to talk with an Oracle database, for example, then you would need to install the whole Oracle API on the client side. That's like a 70 megabyte download and installation. And then you would not be able to, from that client, to talk with a Microsoft SQL database or some other type of database. So your client will usually be very focused on talking only with an Oracle database, if it was an Oracle database that it started out with communicating with. But with a 3-tier setup, you can actually abstract that away and say that the application server provides some kind of functionality that the client can use, and the application server makes sure to talk with the database in the way that the database needs to be talked to. That means the clients do not need to have knowledge about what type of database is in the background. And then there are the situations where it's not true. And the situations where it's not true is if somebody remember the old ASTA way of communicating. You probably have heard about AstaTech in the old days. That was one of the early attempts to make a 3-tier setup for Delphi. But essentially, it just made sure that a SQL statement could pass from a client directly through the application server and into the database. But the SQL statement then needed to be formatted in a way that the database understood. And that means the client would still be kind of relying on what database would be in the background. And that's not a nice way to abstract things away. So because basically you still have a client that cannot talk to a Microsoft SQL database because the syntax for the SQL statements are different. That's in some cases anyway. So the real abstraction level should be that the client does not need to know anything about what type of database in the background. It just needs to ask for some data, and that will magically appear at the client side. And then you have a 4-tier, which is also quite usual today, a 4-tier setup where you have a browser. That's the first tier, Chrome browser or Edge or whatever you're running. And then you have a web server, and then you have an application server. The web server talks with the application server, and the application server talks with the database. That's that's what we are using when we are running a REST setup. Except in kbmMW scenario, we usually combine the web server with the application server, so that ends up being a combined simple tier in the middle. One can abstract it away, so you have a separate web server that forwards things to an application server still, but you can combine them and they will work fine. The kbmMW structure. By the way, if there's any questions, then don't hesitate to stop me and ask. Then I know somebody's awake.
I think they may all be muted right now. They'd have to unmute their mic to ask the question.
Then I suppose they can raise a hand or something, can't they? Somehow in the system.
I'll unmute everybody and go ahead and feel free to. Wrong one.
Okay, the structure of the kbmMW, the software basically is like this: that you on an end user PC. Whoops, I can actually move it here. You usually have a graphical user interface of some kind, and you have your business code, and the business code is asking for data from an application server, usually via a connection pool and data caching mechanism, which is then talking with a transport. And the transport is something that understands, how we can move data from one place to another somehow. It's usually a TCP/IP-based transport, but it could be any kind of transport. It could be a serial port, or could be something else. Actually, if you are very clever, you could probably make a pigeon act as a transport. It will probably be a slow. There will be some latency in the message sent, but anyway. And then there can be some kind of encryption or something in the end of it, so you can secure your data. On the server side, on the application server side in kbmMW, we have similar layers of code. We have whatever encryption is put in front that needs to be supported. Then we have the transport, and then we have a kbmMW server instance which takes care of handling the request and sending it out to whatever services that are able to process that request. And we're talking about services in kbmMW. That's not an NT service as you'll know from Windows, where you can have an application, a program running as a service in Windows. That's not like it. It's not the way that it's understood in kbmMW. A service in kbmMW, that's a module, a compiled-in module, which provides a certain kind of functionality for the clients. It could be, for example, a query service, which we have up here, which allows the clients to ask for data from a database. Then the query service will take care of that and manipulate the data in some ways if needed. Or it could be a custom service, which is the most normal way today, I would say, to use kbmMW. Actually, not a custom service, and it will be a descending of a custom service called a SmartService. But that's a service that just basically has some business code built into it, like adding two numbers together if that's the functionality you want to provide to a client. So if the client is asking for a service that can add two numbers, then that custom service will be the one that responds back to the client. And all of these services, they can be configured to have at one or more running at the same time. So you can service many simultaneous requests at the same time. If we're talking about the query services, then they will usually talk with a database adapter. And the database adapter is a kbmMW thing too, that is abstracting away all the databases. So you can have a singular way to talk with databases from kbmMW servers, and all the strange things that is happening behind the scenes to be able to talk with an Oracle database or something else will be taken care of by kbmMW. At least the translation of things will be taken care of. And then we have a database API, which could be the Oracle API. It could be something else. It could be a DevArt or FireDAC or something else that will be acting as a database API. And then we have the database that we are communicating with. And as shown here, there can be multiple database servers handled from one application server. That's up to how one programs the application server. So that's just a quick overview of the basic kbmMW structure as it has been for the last 15 years or something like that. But since then it has, the structure has been good in the sense that it has been able to be very stable because it's been a plug-in kind of structure where you can, okay, we want to have a different transport, so we can make a different transport and plug it into the existing system in the existing framework without having to rewrite stuff. We want to support a new database, then we can plug in a database adapter, and that will work with the new database. So the whole system is a kind of a pluggable system that can be extended at will. And for that reason, kbmMW today has moved, quite a long way to make things much easier. I will show that in a moment. But it's all still built on the old original way of doing things behind the scenes. Okay,
Kim, I'm gonna switch this over to discussion mode, so in case anybody has questions, they can
do that.
Chime in, and hopefully I don't lose anybody. But we're gonna switch over right now.
I'm still here.
Okay, good. I'm here, and now everybody, if you unmute and you decide to ask a question, you should be allowed to do that. Can we hear some from? Hey, Jim, can you hear me? Oh, they should be able to unmute themselves. Oh, looks like Paul can talk now.
Okay, cool. Thank you, Vadim, by the way. I'm not noticing so much of these comments here, so I'll look them up afterwards. So if you're writing a question on the comments, then somebody has to point me to it while I'm talking, because I'm not able to see them while I'm doing the presentation because it's minimized. Okay, you're still there, everybody, because my sound changed.
I guess yeah, somebody's got their mic open, so it's just a little bit different sound. Yeah, we're good though.
No problem. Okay, transport layers. Well, we have a couple of transport layers supported in kbmMW. We have Indy-based transport layers, and that's kind of legacy layers now, but they are very much in use, and that's because, well, Indy is a standard thing in Delphi, and usually Indy works quite well. We have for a long time also supported Synapse. We also, back then when there was something called DXSOX, we supported DXSOX. That's not the case anymore because it's been a project that has been abandoned for a long time, the DXSOX transport project or TCP/IP components. Then we support IS API transports, which means that we can hook into a Microsoft Internet Information Server directly and let an application server run under that. And we support also HTTP sys, which is a very well. It's written on the same line as the API because an enterprise, Microsoft Information Server, Internet Information Server actually runs on HTTP sys. And it's very efficient way to do web communication because it's doing something called I/O completion ports, or using something called I/O completion ports in the back. So it's quite scalable and quite fast. The problem with HTTP sys and the Internet Information Server is that it's been found to be buggy, and there has been a pretty nasty thing which came out with. I think they have actually partially fixed it now, but it's only a couple of months ago you might have noticed that that there was a huge vulnerability in the HTTP sys that could open your system wide open for the whole world. So then we can also use something called local, and local means that you can combine an application server and a client into one monolithic application. And why would you want to do that? Well, if you want to make a system that can be scalable all the way down from a single person running on a single PC with a single application with just one exe file and nothing else, all the way up to that you want to have 1,000, 2,000 people running towards load balanced application servers and everything like that. You can do the whole thing in the same code. And then you can just choose to compile it in different ways if you want to compile it for local use or if you want to compile it for distributed use. I would not say the local transport is used very much because, what's the problem of delivering a server together with the client on a person's PC? So, I would usually recommend not using a local transport, but there has been some situations where it can be usable. And the latest additions to the transport layers are the kbmW's native high-performance TCP/IP transports, which supports SSL also directly. And a variant of that is a WebSocket support. So we have full WebSocket support also in kbmW. And the good thing about kbmW's native high-performance TCP/IP transport is difficult to say. I should probably find an acronym for that. Is that it's also running I/O completion ports on Windows and is using the fastest way to communicate on Linux on the Mac platforms too. So it's extremely scalable and extremely fast. And I made somebody published a benchmark about the performance of Node.js and various other application servers and software some time back, and including the competitors from in the Delphi world, like from TMS and Synops, what is it called? Well, I don't remember right now. The Synops multitier solution also, and well, they perform pretty well. But I decided to try to check it out. How does they actually perform in general against Node.js? Because everybody has been saying that Golang and Node.js are very, very fast and very, very efficient ways to make application servers, and they are actually working quite well. But what the test showed was that a Delphi-based solution was faster. And if you use the kbmW's native high-performance TCP/IP platform for that, you got the fastest options of all. So that was quite cool. Okay, so we're going to talk about the VIP messaging framework. And the messaging framework is, well, we can communicate in two ways, I suppose. That's the typical way we communicate, is that we are in a request response mode, where we are asking a database, give me some data, and the database responding back. That's the normal way to do things in most ways. So in Midas, in DataSnap, in most other, in REST, whatever, then you're making a request to a server, and the server is responding something back to you. But in a messaging framework like this, we do not work like that. There are nothing that's called a server, and there's nothing called a client in this scenario. Of course, in reality, there are some things that we are defining as a client because we want to sit and look at something. And in reality, we are also defining something as a server because there's something behind it providing some data for us. But all of these entities around in the network are called nodes in the messaging frameworks, because all of them can actually receive and send information whenever they have something they want to receive or send. They can ask, not request something, but simply say, if there's somebody that has some information of this type, then I'm interested in it, and then just give it to me. Then it will come automatically into that application, into that node, and the node can do with that information what it needs to do. For example, rewrite it or augment it with some extra information, and then publish that information out for other nodes that might be interested in it. So it's a very loose way to communicate with each other, and it's a way that does not require a specific knowledge about who you actually talk with.
We have a question on the WebSocket component. Do you have any plans on making a WebSocket component for the client, VCL or FMX, FireMonkey?
Plans and plans. Well, my plans is fairly fluid. And they usually change when there's a need for something in my consultancy business. So, but I'm looking at I've been asked quite a number of times to do some client components, basically some client components for different things, like accessing whatever things on the network, on the internet. And in that sense, it will be it would be a natural thing to make a WebSocket client too. So it's not like it's not something I don't have in mind, but it's not something that's been planned to do at this moment. But it's something I've been asked quite a number of times now. So well, I hope when there will be a little bit more hours in the day, then there will be some time to do that also. Okay. Yeah. Well, we're talking about message-based information sharing here, and that means that everything you want to exchange between the nodes, they're called messages, and a message can contain everything, anything that you like. It can be binary data, it can be XML, it can be simple arguments, simple data like a normal arguments that you use for a normal function call. It can even be objects that can be moved forth and back. As I said, it was public subscribed oriented. Means that somebody is asking for, saying to the system, I'm interested in this type of messages, and they are saying, okay, I have this kind of information that I want to present to all of you right now, and then they are publishing that information. It's also queue-based, which means that when the message comes into from somewhere, is coming into the application, then it's put into a queue, and that means that the application can take care of those messages in the speed it's able to handle them. And when it's sending something out, publishing something to other nodes, then it's also put into a queue, and then it's sent from that queue. And the good thing about that is that you can actually have multiple queues, so you can take your message and push on multiple queues, and then you can have multiple networks you want to interact with at the same time with the same kind of message. So you have a way to forward your message to different places, depending on what you need to have forwarded and how you want to forward it. So you can build your topology, your network topology as you want. And then we're getting to something called network topology, and that means how are the nodes actually connected with each other. There are ways, I've not put up a slide on this, but there are ways to do that. For example, like if you have a broadcast thing, you're just pushing things out, broadcasting things out by using UDP transports, then everybody on the local LAN will be able to listen to that information, and everybody will be able to subscribe for that information. Or you can have a kind of star topology where you're putting a central thing in the middle, we call a hub, and then we have the spokes going out from the center out to the clients, or to the ones that are, it's not clients, the nodes that are out in the periphery of the hub, asking or providing data. And then it's the hub that is the central sharing thing that is deciding who is going to have what. If we're using the flat kind of UDP kind of thing, then it means that you can saturate your LAN quite easily if you have very chatty nodes, because all of the nodes will just send information out when they have something, and all of the nodes will also receive information, but will then filter them out and say, okay, this is not for me, okay, this is also not for me, and okay, this is also not for me. There's one for me. This message I'll pick up and process. But if you're using a hub and spoke topology, then you have a server or a hub in the middle that will take care of saying, okay, this spoke has asked, is only subscribing to this and this and this type of message. So I'm not going to send every other kind of message to that spoke. And that means that the spoke does not have to sit and filter everything. It will still do that, but it will actually only receive the messages, usually only receive the messages that it's supposed to get. One can prioritize messages. As I said, all messages go into a queue, and then you can say, okay, if you have 100 messages in a queue that has not been processed of some reason, has not been forwarded to the next node of some strange reason, performance or whatever, then it could perhaps be a good idea to be able to send a very important message that is saying, okay, cancel this thing or whatever, what you're doing right now, because what I'm saying with you right now is more important. And then that prioritized message will be put in front of the queue. And we have 128 different priorities, so there's a vast possibility to up and down prioritize things. We can also do quality of service definitions for the messages, saying that this message is of extreme importance, which means that it's been acknowledged and double acknowledged, and it's not been removed from the sending queue before the receiver has actually acknowledged that it has been put into the receiving queue and processed. You can also on the sending side say that this message should only be sent when a number of other messages I'm producing are also put into the queue, and what I'm saying that they should be sent. So then a whole batch of messages can be sent. And to prevent a lot of small messages to fill up, take up latency and stuff on the network, then it can also automatically batch messages together if one allows that. But that's also something that can be defined by the quality of service settings. And as I said, since it's queue-based, one can always forward a message to a next queue. And that means that you can actually have a lot of nodes it's going through. Let's say you have one node somewhere in Spain, and then that node is publishing some information about what the temperature is in Spain right now. And that is picked up by a node in Brussels that is then saying, okay, the temperature in Spain was like this, but I'm sure that somebody in Denmark also wants to know what the temperature in Spain is. So I'm publishing out on the other side of my on my node here to the direction of the Nordic countries. And then suddenly the information will trickle up to me in Denmark and say, okay, I know the temperature in Spain now. So this way it's possible to move messages through many tiers. You can actually have many tiers on the way. And it's also tracking all those movements, so you can actually also find your way back if you should be able to, if you at some point want to respond back to a message that you have received, specifically back to the person that has, or not to the person, but to the node that has been sending the original message forward.
Have you done any testing on this to see how many messages per second you can actually process?
Yeah, it can easily handle 10,000 messages per second. So it's pretty performance oriented, and of course it depends on a lot of things what you can process, but it's quite efficient. One of the examples I have for this messaging framework is a remote desktop thing that is possible to download for free actually, and it's also included with source and everything as part of the kbmW Enterprise Edition. And it's a full-fledged remote desktop system that you'll see as a TeamViewer kind of thing with most bells and whistles from TeamViewer, except that it does not support audio. But that's more because I haven't bothered to make that support. But everything to do with screen and mouse movements and keyboard handling and optimize the sending forth and back and all that kind of stuff, that's handled automatically. And you can actually use it for something like we're doing right now. Present so many people can see the screen at the same time, and even many people can control the screen at the same time. So it's quite complex, complete system. It's been used. This messaging framework was actually originally designed a long time back when I was working on some court systems, together with the American company I was assisting at the time, and it was supposed to be used for evidence filing, and it was also supposed to be used for transporting video for when people are giving what do you call it in English, evidence, and when you are supposed to meet in court and you are supposed to give your
deposition.
Yeah, exactly. And because it's expensive to transport prisoners forth and back to courts and between courts and prisons, then and we're talking about 15 years ago now. Then there was talk about couldn't that be made more efficient so you can save those transports and then just do this depositions from the jail, and so this was actually designed from start to be able to move video also. Okay, and now I promised that we would show some code, and that's the time where I'm going to do that now. So we are going to open. Can you see this screen I have right now?
Yes.
Okay, I'll probably make it full screen so it's easier to see. I'll do open project, go down to my lots of demos, and here you can find simple messaging, and I'll find a hop like that. This is a simple node that is able to act as a hop in this messaging scenario. And what we see here is it might be a little bit blurry to see, but what we see here is we have a messaging transport, and we have in kbmW many different transports, server transports here. We have lots of different things here: local server transport, TCP/IP, the new native fast one that's built into kbmW now, a messaging version of it, a WebSocket version of it, an HTTP sys, and all those. There's also an RTMP gateway transport, and so forth. And anyway, in this case we have chosen the Indian messaging server transport. And this transport, what it does is it's providing that bus functionality for this application. It needs to have two queues connected, an inbound message queue and an outbound message queue. Oops. And this is these two here. And they're taking care of receiving messages and storing messages until they can be sent. And I'll just show them how it works, just because this is boring to look at. I'll just show something that actually, so you can see how it looks when it's doing something very simple. If I can figure out where it is down here. I'll find the hub. It's there. And I will do something. I'll subscribe for this funny character. And I'll show what that, I'll explain what that means in a moment. And then I'll start a spoke. I'll probably even start 2 of them just for the fun of it. 1 and another, like that. And then we'll minimize all this crap so you can see what's going on. Like that. And this one spoke up here. It wants to get a node ID, and I want to call it node 1. And this because all spokes have to be having a unique identifier. Actually, if I'm not calling it anything, then it will be given a unique identifier. But right now, I'm just giving it a name. And I'm also saying this one will going to subscribe for this funny character here. And I'll call this node 2. And I'll say this one also subscribe for this funny character. And then I'll say activate. And then you can see actually something happened over here already when I say activate on this client node. The hub suddenly received kind of some different things. It received some subscription information from that client or from this node down here saying that I'm subscribing with this and this and this. We don't have to go into details about that, but it's just to tell you that there's something arrived down over here right now. And that was the client telling the hub what he's subscribing for. And we do the same with node 2, and there's coming some node 2 things in here. And if I'm sending this message, hello world, right now, you'll see that message is coming out to this client or to this node and to this node down here, because both of them, they're subscribing for this character, and this character means everything. I want to get everything. It also means if I'm sending hello hub back to this one, then the hub will receive this message, but this client, this node down here will also receive this message, because they are all subscribing for everything. So this way, doesn't matter who is sending what. Hello all, then everybody will receive the same kind of information. And that's fine if you want to have everybody receiving the same kind of information, but well, we might not want to do that always. Sometimes we might want to limit our subscription, and we can limit it to, for example, something like this: message dot sub1 dot anything, and then I'm announcing that. So if I'm saying hello all now down here, then the hub over here will receive hello all. I will just remove this so we can see it happens. Both here you can see it happens, and this log down here. This is sent. This received hello all, but this one didn't receive anything because it doesn't subscribe for a message that's where it's written hello all in. It will show something if I'm saying something like this, hello all. Then we'll suddenly react up here because now we're subscribing on message.sub1. And whatever comes after that. So that's a way we can build a hierarchy, a message subscription hierarchy, so we can subscribe on different things, different places where we need to, where we are, depending on what we're interested in, basically. And as you can see here, this is a dot notation, this subscription kind of thing. And actually, it's not for fun. I've called it message because although I'm sending a subject that's called hello all, you can actually write anything as a subject, like you're writing a subject as a header of an email you're sending. Then you're writing a subject also as part of this message. And this is the subject that we're actually sending. This is actually not the contents. This is just the subject we're putting in. But that subject has a potential format that we can provide, and that's a dot format where we can write like this, and then something dot something dot something more. And for that reason, we can make a hierarchy and say, okay, we want to receive everything that is following that hierarchy, but this in between might be, or this last part might be, doesn't matter what it is, we want to receive it, or this in between might be, we want to, like this. The second part of the subject can be anything, but then there has to be something, and then it can be anything again. The rest of it doesn't matter. Doesn't matter how many parts there are. So this is a different way to communicate, but it can be used also for making requests and replies. And in this case, we have a different kind of subscription that has to be made. Rec. Dot like this. Actually, there are a lot of more parts that one can subscribe for, but I'm not going into details on that. But it means that this client is now, or this node is now subscribing for all kind of requests from other nodes. This node has said, okay, I want to accept all kind of requests, and a request is something where somebody's saying, I have some information here for you, but I want to have a reply back. So it's a kind of request response scenario, but over messaging. And if one is making sending a message about something, then one will be sending a request dot and then something over here. It has to be a very specially formatted message. So I'm not going into the details about how it's formatted. There are functions that's doing that all for one. So that's yeah, that's it, how it is. And this one, in this case, it wants to have a response back. Well, it's getting response back right now because we are subscribing for anything here. But if we had only subscribed for like this, then we would not receive responses. So we will also have to do like this and receive all types of responses that's coming back. But this is a bad idea because then we are also receiving responses that is intended for other nodes. And the whole point, that's why I'm saying that this, the number of parts here are many, because one of the parts that is included in this, that will usually be part of a response subscription is this node's node ID. So in this case, there will probably usually be standing something like this. So it will only receive responses that is intended for itself. And that way you can filter out responses from everybody else. But it could be a good idea, for example, to be able to take responses from, accept responses from everybody in the case you want to do some kind of logging or auditing system, so you can save everything that's been sent through the network for security reasons or for debugging reasons or whatever. You can follow in to what's being communicated forth and back. Okay, just show the simplicity behind them. The code down here will activate. We're just saying listen to the transport, and the transport itself, well, it has lots of properties can be set, but the most important thing is this binding. It's listening on port 0000, which means that it's listening for all network cards on port 3000. And that means that the clients, they should connect to the hub, or no other nodes, spokes out there should connect to the hub on port 3000. And well, then it has the message queues connected, and these are file-based message queues, which means that in case this node crashes of some strange reason, then the information has been sent to it, but still not processed, will not be lost. At most, the last message that's been sent to it will be lost. The other messages that may be in queue, they're still in queue, and they will be recovered the moment that it starts up again, and will continue to process those messages. So activate is just making it listen, and when we are sending something, we are providing a client identity because we should tell who we are. We can provide as much as little as we want, but it could be that the other end require that we should provide some more information, some specific information for accepting whatever we are sending to it. And then we are doing a send message from our own transport with whatever subject we want to send, and we can put arguments over here. And those arguments, as I said, can include objects and other things. And the moment we receive a message, then there will be a message event triggered, and there will be put into a memo the message we received, the subject of the message. We'll just put into a memo. So it's fairly simple, but it's extremely advanced. Well, I will not spend more time on it unless you have some interest in knowing some more about it, because it is not for everybody to use messaging frameworks, because it has its usage for some things, and for other things it's not really interesting. I can tell a scenario where I'm using it quite extensively, just for giving an idea. One of the places that I'm providing a lot of time for is a company called Danvect, which means translated to English means Danish weighing systems, and they are providing different kind of scales, for weighing trucks and other kind of things, for agro, how do you call it, farmers and other things.
I would think this would be pretty handy in going from a mobile application to a server as well.
Exactly. That's exactly a good place to use it, and that's where it's been used also in this case, because we want to distribute a system to the clients, to the customers out there, where they own their own data themselves, where we don't have to store the data in a cloud somewhere. That's the usual way that many other people they do. They allocate a database in the cloud, and then they are saying, okay, every mobile phones and whatever, they are communicating with the database, and that's the central point in the world. But that also means that the data is not owned any longer by the individual customer, the individual client, the individual company. It's suddenly owned by whoever owns that cluster out in the cloud. And that's going to be some legal problems about that in Denmark, for example, because of GDPR. As you have probably heard, in European Union, we have some rules about how data has to be protected and handled. And we prefer that people do not put data in our hands if we at all can avoid it, to get them. We better like them to have the data themselves on their own machines. So we put a server inside their firewalls, and that server has to be accessed somehow from the outside if you want to have a mobile phone to access that data. And for that reason, we have a proxy server put out in the cloud, where the mobile phone communicates using messaging with that proxy server. And the only thing the proxy server is doing, well, it's doing a lot of other things, but one of the main purpose of that proxy server is simply to figure out, okay, which customer is this mobile phone interested in communicating with, and then it's forwarding that message to that customer server. And this customer server is then forwarding message back through the proxy back to the mobile phone whenever it's something that's specific for that mobile phone. Or when there's a weight change for that everybody is connected at the same time wants to see, then it's informed to all of them at the same time through that central thing. So that's a way to, that's a really strong way and a powerful way to share data, and that's used. This messaging is what we're using for that purpose.
Your sound is cut out, Kim.
Oh, can you hear me now?
I could hear you the whole time.
Yeah, I had no problem hearing you. Yeah.
Oh, that's good. Okay. So that was just to give you an idea about what can be used for this messaging thing. Anyway,
I did have a question, if you guys can hear me.
Yeah.
So I deal with stock market data, which can be hundreds of thousands to millions of messages per second. And I heard you say earlier that you're pretty comfortable with 10,000 messages per second. Is that correct?
On a single server with a single node, with multiple nodes but a single hub.
Okay.
So, but if you're running a system where you are going to run millions of messages per second, then you will have a lot of servers or hubs or processors nodes put up that is handling that load, and then you'll share the load between them.
So the other question I had was, does it have any multicast intelligence in it, so that if the subscribe nodes happen to be within a vicinity where they can receive a multicast, is it able to do that versus sending each one a message?
Currently, the transports are not doing multicast, but it's a valid question, and it could be done with a smarter set of transports. Oh, there's a lot of noise in the background.
There's a bathtub or a espresso machine running somewhere.
Somebody taking a shower.
I actually have NVIDIA broadcast on my mic, so it cuts out everything except my voice with artificial intelligence. All right. So anyway, what was the other question I had? So basically, this is this is cross-platform. It'll compile Android, Linux, everything, right?
Yep.
All right. Well, that's really good from a standpoint of being able to talk, like we talked about earlier, where it can interact with a Windows app and a iPhone, for instance, where we can use Delphi to compile on all those targets, and then we can use your communication at the back end to communicate validity between them.
That system I'm talking about is running on Windows server side, and it's also got Windows nodes, client nodes, because there's terminals and other things that are running on Windows, where chauffeurs can do touchscreen things, and then it's running on iOS and Android for mobile phone terminals.
And I might have been distracted, but did you have a projected limit on single thread server to the number of spokes that it can support?
Well, it depends on the size of the message. If you're sending huge messages, then of course it will be straining it quite a lot more.
Okay. And then your file messaging queue allows it to hit the server for the messages that it's missing and fill those in automatically.
Yeah, you can on the server. Well, and if you're talking about TIBCO, and that's probably what you are comparing with, then you can bootstrap some things from TIBCO, where you're saying, okay, I'm starting up a new node, and that node needs to have something served from a lot of messages to be able to start up properly. And you can do the same actually also from this framework, but it's not automatically done.
Yeah, the TIBCO is a pricey back-end solution that I've been doing this for 30 years, and we avoided TIBCO like the plague. But I was going to say that even though it may not be good from the trade or the bid and offer updates of a stock, and this might be an interesting solution for fixed communication. In the sense, but usually fixed communication is even one-to-one, but I do like the message queuing aspect of it, that it could potentially, that's one of the number one problems with doing order executions with the fixed communication layer, is if the communication breaks and this thing's sending orders and this thing's telling you that they've been canceled or something like that, and your communications is down and you don't know what happened until it comes back up. So anyway, I was just saying that's one of the aspects that I kind of found interesting as well, even though, and that's a lower throughput, that 10,000 messages per second fixed communication could fit under that for a regular algorithm.
And then we have we have all this messaging processing features also built in, so you can have a processor built on top of that's accessing the queue and making sure to do things in synchronous, asynchronous ways one at a time, and other things like this. So you can process the messages and do whatever you want with the messages and shove them into a different queue that's then been handled by something else, and forwarding perhaps that information to that queue, or doing some extra processing again. So it's completely flexible how you want to build the topology inside your application with that.
Okay, thank you.
You're welcome. Okay, so I will go back to my slides here and look at the next thing, and that's the object notation systems that is built into kbmMW. And with, like most things with kbmMW, then if it's not built by me, then it's not good. Well, that's been kind of the mantra I've been working on for quite a lot of time, because at some point in time, well, there was not really a good JSON support. At some point in time, there was not, the XML support has been fairly good, but it's also always been requiring some external components in Delphi. And I kind of liked it to be able to to have it in native code. So I built my own complete XML interpreter, a parser. And well, that's been how it's been going all the time, and been adding new stuff to it, so it's able to parse and produce these different types of formats, whatever you can call them, and it's actually also able to convert between them automatically. And I'll show you how to do that. It also has XSD support, which means you can understand and read an XSD sheet XML definition file, and based on that, it doesn't have to produce a code that is only able to read XML. It can produce code that it can read JSON the same, following the same format, with the limitations, of course, that JSON is more limited in expression than XML. It has object marshalling support, which means you can define a Delphi object and say, okay, I want to have this marshaled as XML, or I want to have it marshaled as JSON, or if I want to have it unmarshaled from XML or from JSON or whatever the other formats it's supporting, back to an object also. It's also able to analyze documents, which means if you have an XML file or a JSON file well, I do not have an XSD to produce all the objects, the Delphi objects for you, then you can actually automatically analyze that JSON file or whatever file it must be, and figure out which objects should be created and define that Delphi code for you automatically. And it's doing a pretty good job at doing that. So you can actually, most of the time, you can actually just compile that and use it directly. Okay, let's go and check some code out for that. And now my earphones are eerie quiet, so I'm not sure if I'm still on, but I hope I am.
We got you still.
That's good. I just have to figure out what the demo is I'm going to show you. I made a cheat list over here. Obviously called object notation. So I should just find that one. Probably on the O, down there. And this is a fairly extensive demo in the sense that it's actually showing all of the formats I can read and write. And well, let's minimize this one. Well, I didn't make much of much support of resizing that one. Anyway, let's check a JSON file. There's a sample built into this one right now, and I can parse it, and we see an object notation tree. And that's the whole thing about this object notation framework. It's always producing when it's reading something in, it's producing an intermediate tree of data. And one can, it's been visualized here, the tree has been read in, and we can probably find all these kind of things, the paragraph down up here. That's the one that's down here. And the good thing is that we can also automatically save it from that object notation to, in this case, a JSON format again. And then it will be very similar to the one we have already used. We could have asked it to produce a prettified one, but there are some properties to set up on the streamer that can define how it's supposed to look. But basically, it's the same document we're getting out of it as we put into it, except that it's well, it doesn't have any line fees right now. Or we could ask it to produce an XML file, not an XML file, an XML document. You say save to memo, and we have an object here with exactly the same thing as the JSON. So that's a way. That's a very easy way to transform it to YAML also. If there are some people using YAML, I'm kind of getting fond of using YAML. I thought it was a stupid thing when I started to. I had the unfortunate mistake of working on Java and becoming an expert in some Java things too. And actually, well, it's not unfortunate because I learned a lot of things also while doing that. And some of the good things from Java and from the frameworks around Java, I stole those ideas and put it into Delphi in the kbmW framework. And one of the things that I stole was the support of YAML, because it's a kind of a cool format where it's very human readable. You can see that the objects, I don't know if you know YAML, but objects are defined by a name and then a colon, and then you indent the properties. And they just have to have the same indentation all the way down, and so forth. Yeah, it's a nice, easy thing, for example, to use as configuration files and stuff like this. And I'm using that quite often now in many places, also in the framework itself. So I'm fond of that. Or if you could have it also saved to JSON, well, then it's a more compact thing. And or message pack, that's even more compact. And the point about message pack is that that's also the frame, the streaming format that is the kbmW is using it automatically itself when it's streaming objects. Then it's actually streaming them in message pack format. Okay. Well, it can read CSV files. Well, that's not something really new, but it's able to understand those. And they can also convert those, for example, to a JSON format. So it's an easy way to convert forth and back. And text files, where there's a fixed format setups, one can define the format up here and the length and the types and how it's supposed to be understood, and then it can pass this down here and do something with it. So that's a easy way to do things. And one can also make an object notation tree by hand. And one is doing this by defining, well, an object or an array typically, and then setting some values for its properties, date, name, whatever, define some properties, and saying that it should be as a double, or it should be a string, or it should be something else. And in this case, we're also creating an array, putting some values into that array of various types, and then putting that array in as a property on the object. And then it's building a tree view at the end down here. There's some binary data also we can put in and so forth. So it's and of course this object could be converted directly to JSON or XML or the other formats that makes sense to convert it to. Basically, it does not make sense to convert this to a comma-separated file, because it's too unstructured to be able to be converted successfully to comma-separated files. So you will lose data in this case, as some of things will not convert nicely. Okay. And then there was the marshalling thing. That's another interesting part. I have to check my object marshalling. It's called XML marshalling. I'm getting old, I can't remember anymore. And we run this. So what I'm doing now when I'm pressing a marshal button is that I'm converting an object that is a Delphi object to XML. And it's showing up here what's actually in that XML object. And obviously, you could just say that I don't believe this, because it can be anything happening, and this is just something I'm pasting in. And I'll show that's not the case. But I can also unmarshal it, and then that's actually what we're getting out of it. And we're getting some records, and we are getting some an icon out also. You could have done it to JSON instead. Then it will look like that, and we'll unmarshal, and it will unmarshal again, so we can see the same over here, and so forth. And we can go and take a look at what we're actually doing. when we're marshalling something. Marshalling means that we are converting some object to something that can be streamable in some way. And XML is a textual streaming format, one of the many streaming formats that are existing. And JSON another one, but it could also be BSON, which is a binary format that is more, as I told you, more compressed, or a message pack, which is the most compressible one of them. In this case, I'm defining a tPerson or tMyPerson object. Just bookmark it and go up and look how it looks. And I've made a class here, and I've also been putting some funny attributes around. I'll show you what those means in a moment, but let's just look at the class as the Delphi parts. As we know, there's a public array of addresses, and then there is some dictionary of some kind, and then there's another kind of dictionary, and then there are some more addresses, and then there is a name which can be nullable, which means it can have the value of null. And that's another thing that kbmW introduces, is that you can define variables that can have the value of null. There's an age here, there's some addresses more, and an interest kind of thing. There's an enumeration, some hair colors, and some stuff. That's actually a funny character. How did they came there? Well, and then we have a data set also, just a mem table in this case. And all these things are inside my tMyPerson object. And all these things are automatically being marshaled when I'm pressing the marshal button. Then the question is, how is it supposed to marshal it? Well, that's where the attributes come in handy, because some things we do not want to marshal. It could be that we have some elements down here we do not want to have out in the XML file. They're just helper properties for our object, used for something temporary, not something that we want to have moved to a document, XML document or JSON document somewhere. Then we can actually tell it that it should not marshal that part. Or we could, since we are talking about XML, we can choose to say this element should be all these addresses here, or the age up here probably is more funny to look at right now. That one, my age property, should be marshaled as something called age. So the property will be called age in the streamed format, and it will, if we marshal it as XML, then it will be an element and not an attribute. An element means that it will be a subnode. It will have its own subnode, that was called, which will start like this with, well, basically look like this. Age, and then whatever age it is. Compared to if we had used the attribute up here, kbmW attribute, as we have been doing down here, then it would have been a part of the main object, and it will just be age equal like that, as part of whatever object it is. Oh, Delphi is sometimes too clever for my good anyway. Like that. And now I have to undo all this stuff here. Okay. And that's basically it. And there's of course there's also a possibility to tell, how are we going to marshal the data set? Are we going to put the field names there? Are we going to, and they're going to be tags, or that's kind of elements? Are we going to include blobs? Are memos going to be understood as strings or as binary fields? What are we going to call each dataset row if we are making an XML entry for it? Well, we call it R in this case. We can also define that each field should be called F, and so forth. If we're going to have a version, because the mem table also provides the ability to provide to show the versions of a record if the record has changed, if it's, for example, inserted and then edited and then whatever, deleted at the end, then you can actually, there's maybe 3 versions of that record, so you can actually follow the steps through the lifetime of that record, and you can have those versions streamed out also. And then we have a funny thing up here. It's called a validate thing, and that's when we are reading in, when we're unmarshalling an object. That means that we are taking the streamed version, the XML version of it, or the JSON version of it, and we want to convert that back to an object. Then we can actually put validations on it and say that for this object to be valid, then the property fmyaddress.myzip should be larger than 1000 as a string. And if it's not like that, then it will fail, and it will come out and say, oh, this is not a valid object to onstream or to unmarshal. Yeah. And this one up here defines the root for the object. That means that tMyPerson, when that object is being streamed or instances of that object has been streamed, then they will be called person whenever they need to be identified. And I've set an option here that's saying that it should include only tagged elements, and that means that there should be either an element or an attribute put on them, otherwise they will not be included. If I put something like this, my own property, then that will not be streamed or marshaled and unmarshaled because there's no attribute on it. If I wanted to have that one out as an element, I will put that one up on top of it, and then it will be participating in the XML file or on the JSON file, YAML file, whatever. Okay. Anything more interesting here? Yeah, well, you can look at the object, the class. The classes are simple. There has to be a constructor and a destructor, and it's the same way as you have in Delphi. If there are some other objects in there that they need to be available as a string list, for example. If we want to be able to populate a string list, then it's probably a good idea to have it defined there already. Yeah. A definition of how the dataset should look like, and that's what we're seeing when we are unmarshalling it. Then that's actually the dataset we're seeing. Marshal and unmarshal, and then we see the dataset here, and we see all the other objects or properties down here. Okay. Second, then we can try something else also, because Delphi can also, as I told you, kbmW can help Delphi generate this stuff up here. This object, all these attributes and all these things, it can automatically detect and generate if we provide it with a file that we want to have it to be able to unmarshal. So we click on this button here, and then we'll be selecting dream.xml, and then we'll automatically have generated here a lot of Delphi code, which I'll put into something we can read. We have a notepad, something here. Yeah, like that. So it automatically detected the structure of that file. We can try to open the file also so you can see how it looks, the XML file. I'll probably just do it in here. Probably easier. Dream, yeah. So it looks like this. And well, it's a good long XML file. And it was analyzed automatically, and then it figured out, okay, we need all these classes, and they need to have these properties, and well, they need to be tagged by these attributes and so forth, and then we'll be able to read this. We can compile this and read it. And not only read it, we can generate a new one if you want to. So it's a different, it's doing basically the same as an XSD file is doing, except that the XSD file is complex to make, but of course also has some very rigid structure, so you can define an XSD file with precise the information you want to have in it, and it can be used for validating and stuff like this. This will just look at the data and then generate the classes that you need for handling that data. Okay. Any more questions? Any questions about that? Otherwise, we'll just proceed.
I do see a couple of questions. One was the MWON object is only one of those things at a time. Paul, do you want to explain the question?
Okay, I'll see here. Well, you basically this kbmW ON object. That's one object that can have a lot of properties, and one of the properties under that object, or several properties under that object, could have another one object underneath. So you can actually have many of them linked together, just as you would have in a Delphi class hierarchy. You can have one class that refers to another class that refers to another class, and so forth. And the same you can do with these objects. You can have an array of objects also like this. Then you would have a kbmW ON array, which will then refer to a lot of kbmW ON objects, or perhaps to kbmW ON native, which is just basic strings and numerical values. And it also supports, another question was that if it supports transporting of images. Yes, it supports images also. And then we'll use native, and then we'll contain a binary thing, so it can move all kind of data. And there's some typing going on, I can see. Okay, great. Yeah, so that was the object notation framework. Then we are logging, and let's go in and take a look at that. And I will not spend a lot of time on that, but kbmW contains a quite complex and complete logging system, which means that it supports log manager, so you can actually say that it should log to the system, which means whatever the system means on the platform one is on. It can log to a file, which means that it's outputting stuff to a file. It can also make sure that log files are, when they are reaching a certain limit, then it's closing that log file and making a backup of it and creating a new log file. And it can even clean up after itself, so it only leaves 25 backups, or how many you want to have of the logs. It can log to a list of strings, string list. Could be a memo or something like this. You can share logs multiple places, so it's not just logging in one place, but to multiple places. And can also log to some remote server somewhere. And then it supports something called log formatters, which means that it can actually self-define completely what should be in a log structural. How should a log be structured? I don't think I've provided a standard one, which is contains quite a lot of things, but one can actually turn on and off individual things if one wants to, or if one do not like that, one can actually make one's own log formatter, so it's following a different format of some reason. The logging can also be used for timing things, which means that we can figure out, we can make a log for, okay, we're starting to time something, and then when it's done, then we are doing a log for that will automatically tell how long time it took to process whatever has been processed. It supports debug, information, warning, error, fatal, and audit type of logging. And you can put you can show interest for whatever kind of logging you want. So you can say that some log managers, for example, going to one file, that should only be the debug logs, and there's other logs like audit, you go to a different log file. Fatal error should be displayed on the screen, perhaps also at the same time, and so forth. So you can have a different they can have multiple log managers handling those logs and taking care of each part of the log types. We can log different types of data. This is exception strings, YAML, JSON, XML, streams, bytes, so forth. You can ask for a stack trace. You can, there's a lot of things you can log here. Allocation log and so forth. And to have levels of logging, so you can ask for, I only want to see the debugging, the basic debugging logs or the detailed debugging logs and so forth. So there's different ways to filter whatever is coming out through the log managers. And I'll show, I'll probably need to speed up things a little bit because I can see that I can probably use another 2 hours than those that have already been allocated. And I'm not sure that that will be all that practical. Where we have it again, my cheat sheet. Simple logging, of course, it's called simple logging. Why didn't I think about that? Simple logging there. And this is, for example, a way to prepare a logging system. In this case, I don't have to do this I'm doing here. But if one has already defined, one can define your own logger if you want to do that. But there is always a singleton defined that's called log that you can use everywhere in your application. You only have to make sure that you are putting kbmW log in your usage clause. That's all. Then you have always access. Oops, I'll get back to that place. You have always access to that log object. In this case, I'm saying to the log manager of that log object that I want to ignore exception, that specific exception. So if that one exception has been raised, then I don't want that one to be logged. I don't care about it for some strange reason. Up here, we can see different ways to log. We can, for example, start a timing. So we give it that timing a name. It doesn't have to be an A. It just has to be a unique name. And for that reason, you can have lots of timing going on at the same time with different unique names. So we started, and then we are doing some information logging and a warning logging and an error logging and a fatal logging. Then I'm saying that it should, for some strange reason, I've been telling it, it's just a demo sample, which are included in the download so people can see the different kind of features that's put into the system. I'm saying that it should use a stack map, which means that it's when it's making a log where it's outputting also the stack, then it should present the whole stack with names of functions and all that kind of stuff. So you can see that it's if you know Eureka log or something like this, then this is basically lots of features that you will find a Eureka log. You will find something similar in here, just as a basic part of the logging framework. Now I'm starting to time something more, and then I'm doing an audit and another information with some timestamping things. I can also provide arguments over here. Then those arguments will be output as well. I can log some XML and some streams as a binary. Right now I'm reading in the an executable, and then I'm logging that as a stream, which means that it will be converted to something readable, so it can be put into the log, and it will be converted to a base 64 in this case. That's the default. And then I'm raising an exception, and I'm specifically catching that one and logging that one. But if I didn't do that, then it will automatically catch them, and it will also automatically log them. And then I'm making a lapse, figuring out how long has it taken for A until now, and I'm logging that immediately. and then I'm timing how long did it time for since I started B, and then I'll stop that timing. I'll not look at the time B anymore. Then I'll sleep 500, and I'll also end time A. So, and all this stuff will be put into a log file, and we'll try to run it. And should probably remove the log files I have done here already, otherwise it's not easy to see simple logging down here. I think it's running down there. Text files. Yeah. Like that. So if I'm then running preparing system logging, then I'm preparing a file logging. I wanted to go to a file instead. So I click the prepare file logging. Perhaps I should show what that did also, because I just jumped that one. Then I'm creating a local file manager that is taking care of the log, and I'm telling how many backups should there be. I'm telling where it should back up the files, what it should be doing about things. Should it timestamp the backups, and should it make backups at all? And then I can also default, if I've not said anything, then a file can be 1 megabyte large before it will be truncated or backed up. But one can change that also by setting the properties of the file log manager. And then I'm just simply saying log.log manager, and then saying, okay, it should use the file log manager. Then it's logging to a file instead of to the system, which is default when we're running within Delphi. Then we'll log down to the event list down here. Okay, so we'll log some stuff. And there was some exception that was raised. I'm running in debug mode right now, so the Delphi will also show them. And down here we should see some log. Yeah, you got a log here. And that's how the log file looks like right now. There's timestamp. There's is it an information? What type of data is it? Is it some information about which thread and which process that was running? And then there can come some extra information in here, and then the information that we are providing. And then we asked for a stack dump. That was one of the logs. So we got a stack dump from exactly where we asked for that stack. We have some XML logging down here, and then we logged this write exe file in binary, and we can see that it's actually been output nicely, not as base 64 right now, but as a nice dump that people can read. There was an exception that was thrown, and the exceptions there are usually always provided with a stack trace, so we can see where that happened. And a couple of exceptions that was happening, and then we see the time span for how long time did this take altogether. The time span for A and the time span, well, that was the lapse until then, and then total time for B and total time for A. So, any questions about that?
It's pretty cool.
I can use asserts and so forth also, and it will also act together with the log manager. So, but let's skip over that. Next thing is the object relationship manager, and that's pretty cool. And actually, we should probably use an hour or two for that alone, but we're not going to do that. It's object relationship mapping is something which means you have some Delphi objects, and you want those objects persisted, and you want them somehow to relate to each other on a database. For example, you might have a customer object, and you want to have that customer stored in a database from time to time. And the usual way is that you are making your own SQL statements and picking out the relevant properties from the customer object, and then you're putting that into the SQL statement as parameters or whatever, and then you are executing that SQL statement on the database. And that's boring. Basically, it's just taking a lot of boilerplate code to do that, a lot of typing. And it would be much nicer if we just could take that object and say, put that into the database. And that's what the ORM can do for us. It supports SQLite, Microsoft SQL, Oracle, MySQL, PostgreSQL, Interbase, and Firebird at the moment. And it's also supporting the creation of tables on those databases. So if you have an object, then you can automatically figure out how to create a storage place that after the way that you want it to be defined. And if you change that object, for example, if you put some extra properties into that object, or you rename some properties, or you remove some properties, change the types of them, and so forth, then kbmW's ORM is even able to detect that and figure out if that structure that you have in the object match the structure on the database. And if those do not match, then change the structure on the database so that it will be working again. And it will do its utmost to try to keep the original data in there even after the change. Okay, and probably I should look at the standalone deep over here. And it's a pretty complex, there's a lot of buttons on this one, but it's just because it's showing a lot of different things done in the ORM. Basically, I have a SQLite. It's running on a SQLite database right now, this sample. And I have a SQLite connection pool. That's the thing in kbmW that's connecting with a database somewhere. And just for the sake of it, we can try to see that. Right now, there is SQLite, and there's FireDAG, and DB Express, and a couple more connection pools are supported by kbmW in this installation I have made right now. But kbmW supports something like 34, 36 different database APIs. And one can simply, in the configurations file, define which ones that it should use, and it will compile them in, and then one will find a tab like this one, like FireDAG or SQLite, where there will be a connection pool and some query components and some more stuff. In this case, for the demo, I'm using a SQLite connection pool, and the kbmW supports SQLite directly. It doesn't need FireDAG or anything like that to do that. And let's try to go and look at some objects we have. I'll probably have them over here. I've defined some objects in here. I'll just page through this. A T-person object, which contains an ID, a name, address, age, and count of name property. And you can see that I'm using something called nullable right now. That means that this property will be able to be nulled. It will have to be able to have the value null, or a string, or an empty string. And nullable age, that means it can be null, or it can be positive or negative or 0. So you can distinguish between nulls and not nulls, just as you can in a database. And then I'm defining some information about what do I want the table named that it should be stored in this T-person object. And I've told it the table should be called person. I've also told it I want to define an index, which I called I1. And the index should be on the field name. It could be multiple fields that including that, and it should not be descending. And then I want to define an index called I2, which should be unique, which is covering the field's name and the field age. And the field name should be descending. So I have defined told kbmMW, that the moment that you're going to do something about this T person and actually create some storage on the database for it, then that's how I want it to be happening. And then I've defined for each of the properties how those are going to be mapped. For example, the property ID is going to be mapped to a field called ID with small letters. It should be a primary key, and it should actually automatically generate the key for us, the contents of it. And it's generating using a generator. There's lots of different generators built into it, but one of the more popular ones that I prefer to use is short GUID, which means that it's generating a global unique identifier, but it's compressing it so it doesn't contain the curly braces and the dashes in between. Then it's defining then I want to have the full name put into a table field called name, and the table field should be defined as a white string of 50 characters, and so forth. And then I have a special kind of field down here, which is a sequence thing, which means that it's actually counting how many of that particular name that we have created. So if we are creating 2 people that's called Kim as a name, then the first one will be having the number of count of name 1. The second one will be automatically be number 2, and we don't have to count it. It will make sure to keep track of that itself. It's keeping track of that using some pivot tables. And then we have an account table where there should be some money on it. It should be linked to a person. We have it up here. And some kind of value on that account. Okay. Then we go into the scenario where we want the database to be created. And that's all we have to do is just write orm.create or upgrade table, and then tell it which objects or which classes do we want it to create tables for. And obviously this one orm is coming from somewhere. And this one is coming from up here. We have defined an orm. And this orm is going to be a few places here. There's something called orm. Equal. We instantiate that one here. We created an instance of kbmW orm, and we are saying that it should use this connection pool for the connection to the database. Basically, that's all we need to do. I'm also telling it that I want to use a query mode called mixed, and I will tell you a little bit about that in a moment. But it means that we can use SQL statements. If we want to write SQL statements, we can use SQL statements both in the database native format and in a unified format that kbmW produce and supports. And the unified format has the advantage that it can recompile that one automatically to match each of the databases kbmW support. So one does not have to make a statement for each database type. One can just make one statement and then it will work against all database types within limits, because there are some things that are very special for some of the databases that kbmW do not support. But for the most part, it's able to do that. Okay. So let's try to run it. And if I'm saying create table right now, well, nothing happened. Well, actually something did happen. It did create an upgrade at a SQL database. And just have to find it down here. Orm standalone. We have the database down here from the 26th of 1st at some strange time in night. We can also ask it to delete table, then it will remove all the tables that are inside it, and we can create them again. And then it will, if we go into look what is inside it, then we'll see that it actually contains a person table, an account table, and an image table, because those were the ones that it was supposed to create. And then it also created a spatial count of name table because it has to keep track of how many times have you created a record that is called where the name is of this and this name. I don't know why one should do that, but it could be used, for example, for versioning. If you have an invoice number, then you cannot just remove an invoice necessarily. Sometimes you have to keep that invoice number, but of some strange reason there was written a wrong name on that invoice. Then you can make a new version of it. So the first one was called version 1, and the second one is called version 2. And then you can ask for just the newest one later on when you need to get that invoice. And that's a good way to, for example, to use this count of names thing that I was using down here. So it's actually a version number in that case. And it will all be handled automatically behind the scenes for you. kbmW takes care of that. Okay. Well, we can try to add some records, and probably I shouldn't have closed it because then we can see that we actually have put some records in here right now. Three records, and let's see how we added them. Add records there. I'm making a T-person instance, putting some values in it, and I'm saying it should persist it. And then I'm making an account and referring to the ID of this one up here. And you can see that we did not give it an ID up here, but the moment that we persisted it, then it got an ID, and that one ID is the one that is in the database and the one we can reference now for creating the account. So we know how many money that Hans has on his account and so forth. So that's an easy way to do it. And in this case, we are creating an image, and we want to load that from a file somewhere, and we persist that one. So you can handle blobs and everything like that also. We have down here, the blob is down there. And the accounts, you can see the IDs. That's the short GUID I talked about. And the person ID is here. These 3 accounts, they are all referring to the same person. You can see that. And that's because that's how we defined it in here. We all of them made 3 accounts, account 1, 2, and 3, that was assigned to the P2 ID, which is Kimsen's ID. And then we have the ability to update a record. You can see what an update does. We can change, for example, the name of P2 so it will be Jens Jensen instead. And then we can do an update or insert, or we could do a persist. Actually, we'll be able to do it. It will automatically be able to detect if it's something that's already existing or not. And if it's existing, then it will update it. If it's not existing, then it will automatically insert it. But we can also specify that we specifically wanted to do that in this scenario using update and insert. So in this case, if we look at the name here, Kim Kimsen, that then should change name to Jens Jensen the moment that we click on that button. Update record. And we can try to look in here and say, now it's suddenly called Jens Jensen, because that was the one that we changed. That was the object that we changed the value on. Then we can query something. Or we can delete a record also. Then we just say which record do we want to delete? We want to delete the record, or we want to delete the object basically, and then it will automatically figure out which record behind it needs to be deleted. And in this case is P1. So this object up here which is Hans Hansen. And if we click on delete record and we update this one down here, then we should not have Hans Hansen in. Anyway, not the first Hans Hansen. That was gone now. Okay. Delete all tables like this. You can also purge the tables. That means that we are not deleting the tables, but we are removing all data from them, all what's inside them. Then it's using the fastest way to remove the data that the database supports. And that's usually not a delete from, because that will, if there's lots of records, then it will come along update list for this journal, and it will take a long time to process. So if that database can do a purge itself, then it's possible to do. It's using that feature. Okay, then we can query for things, and we can, for example, say we want to. Oh yeah, good. Then again, we want to query a list of people. And now I'm doing a SQL statement. I want to make a query, get the objects, a list of objects back, and the object list should be person, T-person types. And I want to select from the table called person in the database. And I put some a hash mark in front of it, and that is to say to the framework that I'm going to use the database own native SQL statement. Remember this, I talked about that we can use the native SQL statement, or we can use kbmW's unified SQL statements. In this case, I'm just executing this one statement on the database, and I'm getting the object list back. And we can try to run it and see what happens. Like that. And then we have an object that's been returned to us that contains 2 items. Well, the first item is Jan Jensen with some address, and the second item is Hans Hansen with some address. And then we are throwing it away again just because we don't need it. But we can also do a different query list. That was not the one I wanted. We can do, where we have one. Select, we have a lot of things here. We can do this one. And that's button 6. And which one is button 6? That's probably giving them some names. Query. There's not probably that one over there. Fluent query. In this case, I'm not using this hash mark in front, which means that I'm using kbmW's native and unified SQL language. And instead of identifying the table as person, which is called in the database, we are identifying it as the globally unique name for the class. And the global unique name is the unit it's inside and the name of the class. And the reason why we have the unit included is because you can have a T-person defined in different units at the same time. That's completely legal in Delphi, but you have to scope them out when you need to use them, which one of them you want to use. So in this case, we want to make sure to tell it that it's the T-person from new data, and that's basically it's part of the syntax. You have to tell it like that, so there won't be any confusion. Then it will automatically figure out, okay, this one class, where does that actually exist, and what should it be converted to when we are executing the SQL statement. We can try to run that one. Fluent query, and run that one, and then we are getting a list back. And then it's now, this time it's just a T list we're getting back with items, because that was what we requested, and we are getting those 2 entries back, Hans Hansen and Jan Jensen again. I'm removing the list, and in this case we are asking where there's a full name that is like something. And we can provide a parameter. It should be like Kim, and probably is a better idea right now because I have removed Kim, so there's no Kim in there, so they will not return anything right now. We will probably see that. There's 0 items because there's nobody called Kim in there right now. And we can use a name parameter, and that's also not going to use any, return anything, because that's also searching for Kim. And what we have more here, that's funny again, Kim, with a positional parameter. Yeah, well, we can use t-params for querying. We can use link for querying, and that's, well, we can, in this case, we are asking for, all persons, people inside the person table, and we are summing the age from them. And then we're getting a total sum of the age, which is 65. Of course, we could have select sum if we want to do that instead, but this is just to show that one can actually introduce with the ORM also the link that we have not been talking about yet. And well, that's a way to do it. And so forth. So there's lots of ways to do things here. But the cool part is that the moment well, there are many cool parts, but one of the cool parts is that if I'm putting in, I think there would be needed to have a city, for example, for the person. I just put in a city here. And I say, okay, I want it to be put into the database as a wide string of 60 characters, just to say something. Oops. And we're making a city property. It could have been called something else, but it's of a string type. And they should be referring to this. Like that. Now we have a completely valid object again, and we have introduced a new property, and we want that property to be available also into the database. And then all we have to do is to make sure that this one create or upgrade table is being called. Then it will automatically change T-person, will detect that T-person is missing a field in the database, and will automatically add that field, and everything is back on track, and you can continue working as nothing has happened. Or if you remove the field, it will automatically remove the field from the database. One can actually there's different options one can provide for this create and upgrade table, so you can make sure that there will not be any destructive changes to the tables. So if you're removing a field from an object, from a class, then that field will not automatically be removed from the database, because it could be an accident that you fuck something up in your object, and you don't want to remove all the account values from the account table, for example. Okay. And you can see you can make fairly complex statements. There's a select statement where you are joining two tables, in this case from the person table or the person object and the account object, because I want to have a result back where I'm getting both the information about the person and the value that person has on his account. So in this case, I'm returning a person account object. And the person account object is defined as a virtual table. That means it's a table that does never exist physically in a database, but it's something that can be returned, and we want these informations to be returned. So we can take just a subset out of those other tables and only ask for that subset to be returned. Okay. Time is running. So I'm not sure if I will talk more about ORM. Any questions about that?
From what I see, it looks pretty fabulous.
That's good. Okay, close that one now. And then we have link. Link has something that's known and introduced by Microsoft. As far as I know, they were the first one to call link. And I stole that name because I thought mine kind of looked like link in many ways. But it's something that can operate on arrays and lists and objects and do things with those elements that are part of those arrays and lists and objects and whatever. Sum them together, make averages of them, sort them, and do other kind of funny things. And it can. I think I should probably remove this because that's the whole slide. Let's go and check that out. quickly. And that's a pretty boring thing, because if I'm running this one, it's just doing a lot of things in a very quick way. But I'll just show you that it's doing something, and then I'll show you what's doing behind the scene in a moment. So like this, that's the output. And if you memorize that output right now, then we can go into the code. Okay. So let's go into the code. And in this case, I have defined a class, and I'm saying this class, I want it to be understood by link. That means I want to be able to search it. I want to be able to sort it. I want to be able to do stuff with it using link. And then I have another class, which I'm doing this. I'm also saying that it should be possible to link with. So the moment I'm starting this this project, then I'm running test native. In this case, I'm creating an array down here, an integer array of data with random integer values. And then I'm saying, okay, link.using. I'm using this value here, the aint array. I want it to be sorted according to the value descending, and I only want to show the first 5, and actually don't want to show them. I just want to have them returned as an integer array. So if we stop there, then we can try to see what we're getting out of that. And with a little bit of luck, we're getting that out. Oh, we cannot stop there. Let's stop around there. Like that, then we're getting the top 5 elements which sorted descending from aint. So that's a quick way to sort an array of integers. We could also do something down here, like that. We could also say that, okay, we want to take the aint up here, array, and we want to split it in groups of 3. And we want to get that back as an integer array. So now we're going to get a group of 3. Like we have here. Subarrays with 3 values in each of them. 2 values in the last one. So a split function is also, a simple way to split things up. And we'll run down to the end. And we'll go to test strings. We can see the same one now. We are making a string list, adding some strings to it. And then we want to sort that according to, and very similar to what we did before. And we're getting a new string list back. And that string list now looks like this. We only get the top 5 values. And since the sort, we are sorting alphabetically, then the number 20 is not being put in the top because it's not number 20, actually it's number 20 textually. So it's not been, it's all the way down here. And not part of top 5. We can also ask it to sort it numerically, like that, and then we are getting it like this. Then suddenly we have 20 in the top. Then we can share this link, this value with others, so that we can do many things with the same source at the same time. And for this, in this case, for example, we want to find the maximum value, and it's outputting that one. Right now, it's I probably should have put it into a variable, because right now it's just putting it out to the memo. We can ask for a sum of the values of all the values in this string numerically. We can also select something that from. We only want to have a list where the value is what do you call it, an equal number. So we get 2, 6, 4, 28, but not the other ones. We can ask it to return it as an integer array. So that's an easy way to convert from lists to arrays and forth and back. And we can split that one also, and that's not interesting because we did that already. So we're skipping that one. Then we can look at objects. Let's make a list of objects. There we have this TMyData, and I'm putting some that we defined as a linkable object before, and we're putting some data into each object and adding that to the list. And then I want to get the maximum age. That's 77. Well, it's true. And we're going to want to have the alphabetically minimum name, and that's Hans. And we want to sort the name descending, and then we want to get only the names back as a string list. And we get that one here. So we get the names sorted and only those names back as a string list. Or we can change it. We want to have it returned as a generic list. Then we're finding the ones that has an age of 33. And we want to get that one back as a generic list. That means that we have found 2. And the point of this one TMyData is that, well, now we're getting a new instance back of TMyData. But if we selected a TMyData something else, then it will automatically match which property names match which property names. And for that reason, only the ones that are matching will be returned. We want to find one age 77. I want to get that back as a TMyData object. So now we have an object here that's where the name and address and age are provided. And in this case, as I'm saying before, there's a different TMyData which contains some more properties, like a zip code, for example, and an ID, but the name and address match property name-wise, so those are filled out. Empty objects doesn't matter right now. JSON, well, we can take a JSON object and do something with that. Here we have a JSON object with an array of objects in. And then I'm saying I'm interested in all the items that are under the result object, all the items under that one. And I want to do something with that. I want to find the maximum ID, and that's the value 10. And the minimum ID, that's the value 1. And I want to sort the date over here, descending, and I want to get that back as strings, yeah, like that. And the same we can do with we're loading an object notation in again, but we are doing something else with it. We are also splitting, for example, by name. Then we are getting lots of small lists back, which you can see that this name Kim is coming a couple of times, and Jens is coming a couple of times, and John is coming one time. So it means we're getting 3 sets of values back because we split by name. And we got the first one. It's called Jens. That's all the Jenses that's written there. There was 2 of those. And the second batch, that was the John. There was only 1 of those. And there was the third batch. That was the Kims. There were 3 of those. And it's saved as an object notation, and it's saved as JSON right now because we are using a JSON stream to stream it. Okay. Like that. And we can make a query where we're actually executing SQL statements on the data. We want to get the name and the ID put together as one field. And we want to have that one output like that. Then we have the name and the number with a space between, and the output as JSON. So you can manipulate a lot of things, and the same we have with the CSV and the text and so forth. You take a data set and manipulate that also with the link. So the link thing is an easy way to search and filter some stuff. And also, as you saw, simple objects in this case. Okay. Were there any questions to that? I'll just check.
I didn't see any questions, but we did have a couple of visitors that had to exit out.
Yeah, I understand that. We are also past time, so it's up to you if you want to hear the rest, or if we should cut it now.
What was left? What do we got left?
We've got some major things left still. We got the scheduler, the SmartServices, which is REST stuff, SmartEvents, and SmartBind.
If you'd like, in the future we could, maybe do another talk on that if you want to hold off on it.
For me, I can continue, but it's more if you are up to it, or the remaining people are up to it, because it's getting late over there too. I'm up already, so it doesn't matter for me.
It depends on what everybody else. Chime in and let us know what you think, people. You can turn your mics on if you want.
Can you hear me?
Yes.
Yep.
Okay. I'm just a visitor here, but I think it would make excellent sense as a second half to a talk. Another talk, I mean. I also had a question about the link, like Microsoft Link has a sort of a theoretical foundation in functional programming and category theory. Has that been any influence on you in this work, or?
No, not really, because the problem is that some of those features that they're taking care of, that they're using, applying in Microsoft's way of doing things, is not really possible using Delphi. So it's impossible to make a real functional kind of link in Delphi, unfortunately, as it is right now. This is I think it's called duck typing, where you're basically putting different elements together instead of having as you're seeing, I'm writing a filter, do something with that filter, output something like out of that with a dot notation between them, and it makes it simpler because it can operate on those values and those types that it can operate on, but it doesn't have the full flexibility of Microsoft's link. So it is not Microsoft's real link, but it's something that is cool enough, in my opinion, that it at least within Delphi, the Delphi world could be understood a little bit like that. So. Yeah. Okay, so should we call it for now? I don't know how many were left, and if what the feeling is.
It looks like most of the people left are from other countries, so I don't know what their different time zones are, so it's hard to say.
Yeah.
But like it was suggested, it would be in a couple of months, if we wanted to follow up with a second more in-depth talk on the remaining stuff, that would be fine. That'd be great.
So let's do that.
If you could do it.
Yeah, well, just give me a call and we'll arrange something.
Okay, great. Thanks everybody for attending. And I'll get this recording up as soon as I can. I'll edit out the blank spot and put some titles on it. So I'll post it in the meetup and to the Delphi group.
Great. Thank you for being allowed to attend.
Well, thank you for getting up so early and coming in. I appreciate it.
Well, I didn't go to bed, so that was easy.
Oh, well, now go get some sleep. Thank you, sir. Thanks, everybody.
Okay, bye-bye.
Bye.